Welcome to This Explainer. I am absolutely thrilled you're here today. Look, if you've ever felt completely paralyzed by a complex choice, well, you are in exactly the right place. Today, we're going to decode the complex mathematics of decision-making. We're breaking down a really fascinating framework known as multi-attribute utility theory. As you'll see, we can actually take our messy, complicated human preferences and turn them into hard, actionable data.
Okay, let's dive into this. Think about the last time you bought a smartphone. You know the drill. You probably wanted the absolute lowest price, the biggest screen, a massive amount of storage, and of course, perfect 5-star reviews. But that phone doesn't exist, does it? In the real world, an ideal option rarely, if ever, exists. You have to compromise. Maybe you trade a little bit of screen size for a better price, or you sacrifice some storage for a much better camera. But how do you mathematically guarantee that you're making the smartest possible trade-offs?
And that brings us to multi-attribute utility theory, or Maut. At its absolute core, Maut is a methodology that builds a bridge between subjective human preference and cold, objective mathematical ranking. It essentially operates on a really powerful hypothesis, that every single decision maker is just trying to optimize a hidden function that aggregates all of their unique points of view. By mathematically mapping out this utility function, we can calculate the exact degree of well-being or utility that any compromise solution is going to provide you.
So here's our roadmap for today's explainer. 1. The complex decision dilemma. 2. Core concepts of MAUT. 3. Inside the additive model. 4. Software for smart choices. And finally, 5. Decoding the black box.
Section 1. The complex decision dilemma. So why do we even need a theory this advanced? I mean, why can't we just score things on a scale of 1 to 10, add them up, and call it a day? Well, those naive approaches usually fail, because human beings are delightfully complicated. And honestly, we are pretty terrible at calculating trade-offs in our heads. Our preferences just aren't perfectly linear. For example, think about this. Is a wage of 4,000 pounds exactly twice as good as 2,000 pounds? Well, for some, jumping from $2,000 to $4,000 might actually improve their utility by a factor of 5, simply because it pushes them past a really crucial survival threshold. A simple weighted sum just cannot accurately model that kind of reality.
Section 2. Core concepts of Maut. And this brilliantly illustrates how we mathematically capture those tricky, nonlinear human desires. We have a set of alternatives here. Let's just call them our different smartphone options, right? A, B, C, and D. The Maut model takes each of these distinct alternatives and maps them to a global utility score. Now, this score isn't just some random number pulled out of thin air. It is a specific, mathematically derived measurement of the desirability of that object. It calculates exactly how much well-being that alternative provides to the decision maker when you factor in all of their criteria.
Section 3. Inside the additive model. All right, so how do we actually calculate that global utility score? We use something called the additive model. This is literally the most popular and widely used MAUT approach out there. And we can break it down into 4 logical steps without getting totally bogged down in academic equations. Step 1, we rescale or normalize the performances. You obviously can't directly compare battery life in hours to a price in dollars, so we normalize everything to a standard scale, usually between 0 and 1. Step 2, we apply the marginal utility, which basically adjusts those scores for your nonlinear preferences. Step 3, we weight the criteria, figuring out how much you'd trade on one criterion to gain on another. And finally, step 4, we sum it all up into one neat global utility score.
So the crucial point is seeing how this plays out in a real scenario. In this matrix, which is based on an actual case study, we have 5 smartphones, SP1 through SP5. We've assigned weights. Price and customer reviews are highly important at 35% each, while screen and storage size sit at 15% each. Now, when we run these numbers through the additive model, aggregating the normalized scores and the preferences, the math reveals a clear winner. Smartphone 3, or SP3, comes out on top with a definitive global utility score of 0.654. The compromise is no longer a gut feeling or a guess, it's an absolute mathematical certainty.
But hey, remember step 2, marginal utility? This is exactly what that looks like visually. Notice the piecewise linear function. Utility rises sharply at first, but then it kind of levels off. On the flip side, a decreasing exponential function is absolutely perfect for a cost criterion, like price, which you naturally want to minimize. As the price goes up, your utility rapidly drops off. Different criteria literally change the very shape of our preferences, and the beauty of MAUT is that it captures these shapes perfectly.
Section 4. Software for smart choices.
Now, constructing these graphs by hand is obviously incredibly tedious, right? No one wants to do that. So let's move from theory into practice. This is Right Choice, a software package that actually implements the additive MAUT model for you. Instead of doing pages of complex algebra, the software allows you to just input your data and then perform dynamic what-if sensitivity analysis. You can tweak the weights, like, say, increasing the importance of the smartphone screen size, and instantly watch how the alternatives magically re-rank themselves. It makes robust, mathematically sound decision-making incredibly accessible.
Section 5. Decoding the black box.
Okay, however, there's still an elephant in the room here. Even with software, manually constructing those precise, curved utility functions is incredibly difficult for a human being to do from scratch. To solve this, decision scientists developed elicitation methods like UTA, UDNOG-MS, and GRIP. These are indirect methods. Instead of asking you to define all your mathematical parameters up front, these methods work backwards. You simply look at a small learning set of options and rank them based purely on your gut feeling. The algorithm then automatically deduces the mathematical parameters that must exist in your brain to have produced that specific ranking. It's wild.
Now, what's really interesting here is how the UTIP Plus software handles this process. You enter the raw values for your criteria, like the price, the customer reviews, screen, and storage size, and then you just give the software your ordinal ranking. You literally just tell it, I prefer SB3 over SB2 and SB2 over SB4. That's it. The software then uses linear programming to infer your marginal utility through piecewise linear functions. It figures out your hidden utility curves just by looking at your final choices.
Let's see how this builds with even more advanced tools like Visual UTA, which uses the UTA-GMS method. UTA-GMS addresses a major shortcoming of earlier models. It doesn't force you to provide a complete, perfect ranking. It completely accepts partial rankings and pairwise comparisons. You can say, you know what, I like A more than B, but I'm completely undecided on C. And guess what? The algorithm will still generate all non-decreasing additive value functions that are compatible with your partial preferences. It actually embraces the uncertainty of human choice.
Which leaves us with a truly fascinating conclusion. We've seen how multi-attribute utility theory can map our messy, nonlinear desires into precise objective mathematics. We've seen how algorithms can look at our gut-feeling choices and completely reverse engineer the exact weights and utility curves operating inside our own minds. So I want to leave you with this final thought to ponder. If a mathematical model can reverse engineer your preferences perfectly from just a few samples, who is really making the decision, you or the algorithm? Thank you so much for joining me on this explainer. I really hope you found this breakdown as captivating as I do. Keep learning, and I'll see you next time.